Alright, question 10. The following cylinder has a height h and radius r. A cone of the same base dimensions and height is placed on top. Which of the following formulas will compute the volume of the combined figure? So they want us to find the volume of this cylinder cone shape. And the volume of our figure is going to equal the volume of the cylinder plus the volume of the cone. And so the volume of the cylinder is equal to our base area times the height. Since our base area is a circle, we're going to have the volume of the cylinder is equal to the area of a circle, since it's our base area, pi times r squared times our height. So there's the volume of our cylinder. Now the volume of a cone is related to the volume of a cylinder. It's 1/3 base area times the height. And again, our base area for this cone right here, our base area is across from the peak or the vertex, and our base area is a circle. So the volume of the cone is going to equal 1/3 our base area. The area for a circle is pi r squared times the height. So now if we come back here for our volume of our figure, by the substitution property, the volume of a cylinder is equal to pi times radius squared times our height plus 1/3 volume of a cone by substitution is 1/3 pi r squared times height, 1/3 pi r squared. Okay, now if you look at our options, they have 4/3, 1/3, 1/2, or 2/3. We look at what we have. We have pi r squared h, pi r squared h. But we have, when there's not a number in front, it is assumed to be 1. So I have 1 whole pi r squared h's and 1/3 pi r squared h's. So I can combine these terms because they have pi, r squared, and h. They have all of the same variables. So pi is not a variable, it's a number, but we treat it or can manipulate it like a variable. So I have one of these and 1/3 of more added, so total, the volume of our figure, 1 plus 1/3. 1 can be rewritten as 3/3. So 3/3 plus 1/3 would give us 4/3 pi r squared h's. So the volume of our figure can be combined as 4/3 pi r squared h. Okay, question 9. Complete the formula for volume of a pyramid with the base area b and height h. Volume equals blank base area times height. Enter your answer as the number that correctly fills in the blank. You have to remember the relationship between a pyramid and a rectangle, and it is 1/3, so 1/3. Okay, question 8. Michaela is trying to find the volume of a pyramid-shaped vase. She finds a prism-shaped vase with the same base and height. Michaela fills the pyramid-shaped vase with water and pours the water into the prism-shaped vase. She finds that doing this exactly 3 times completely fills the prism-shaped vase. Which of the following statements can be inferred from this experiment? So inferred means implied or come to a conclusion of based on this experiment. So the experiment was that she took the pyramid-shaped vase, this one, filled it 3 times in order to fill our prism-shaped vase. So what's the relationship between the pyramid-shaped vase and the prism? Well, it takes 3 of our pyramids to fill the volume of a prism. So the volume of the prism is 3 times the volume of the pyramid. That would mean that the pyramid would fill the volume of the prism is 3 times the volume of the pyramid. Yeah. The volume of the prism is twice the volume of the pyramid. No, because it took 3 times. The volume of the pyramid is half the volume of the prism. No, because it took 3 times. If it was half, it would only take twice. The volume of the prism is greater than the volume of the pyramid. So the volume of the prism is greater than the volume of the pyramid. Yes, because it took 3 pyramids to fill the prism. The volumes are the same. No, the volume of the pyramid is 1/3 the volume of the prism. That one is true as well, because if we were to make an equality, we could say 3 times our pyramid, volume of the pyramid is equal to the prism, the volume of the prism. Volume of a prism. So now if we wanted to solve for the volume of a pyramid, since 3 is multiplying, we would use the division property of equality. So 3 divided by 3 reduces down to 1. So I would have 1 volume of our pyramid, or just volume of our pyramid, since multiplying by 1 does not change the value of anything. That's why mathematicians just assumed that if there's not a number in front, it would be 1. Equals, so assuming volume of a pyramid, there is a 1 in there. It's an assumption mathematicians infer. So we have 1 divided by 3, 1/3 volume of our prism. So there's the equality that would prove that the pyramid is 1/3 the volume of our prism. The volume of the prism is less than the volume of the pyramid. No. There is not enough information to tell. Yes, there is, based on her experiment. Those are the 3 things we can come up with. Question 7. A cube-shaped tank that measures 4.6 meters on each side is full of water. If some water is drained to fill a cone with a height of 6 meters and a radius of 2.5 meters, approximately how much water is left in the tank? Use 3.14 for pi and round your answer to the nearest tenth. Okay, so we want to know how much water is left in the tank. So first we need to find our total volume for the tank. So the volume of our tank minus the volume from to fill the cone. That's going to equal a volume that's left in the tank. So left in the tank, LT. So the volume of the tank, since it's a cube, we know our base area of a cube is a square. And the height is also the same for a cube. And so the volume of our tank is going to be side times the base area, which is side, times our height, which is s cubed. minus the volume of a cone. A cone is a circular base that comes up to a point, and our height is measured from the center up to our vertex, and so the area of that is 1/3 our base area, which is a circle, which the area of the circle is pi r squared, times the height. So now we're going to use substitution property of equality. Since the sides of our cube-shaped tank were 4.6, we're going to have 4.6 cubed minus 1/3 times pi times the radius, which was 2.5 meters, times our height, which is 6 meters. And that's going to equal the volume that is left in our tank. So when I enter this into the calculator, I'm going to include parentheses around my whole second group because there's more than one number being multiplied in there, and parentheses indicates groups. So we're going to go to our calculator. We're going to type in 4.6 x to the y, hit the 3, minus parentheses. Since I have 1/3, I'm going to type in a parentheses 1 divided by 3, close those parentheses, times, and they do have a pi button, so I'm just going to hit the pi button, times 2.5 times 6, and close those parentheses because that's the end of my second term. And then we're going to hit enter, and that's 81.62. Is the volume that's left in the tank. And that would be cubic meters. And we want it rounded to the nearest tenth, so I'm going to look here at the hundredth and ask myself, well, if I were to round 62, would it be closer to 60 or to 70? 62 is closer to 60, so we would have 81.60, which is just written as 81.6. Okay, question 7. When I typed it in the calculator, I forgot to type in the square on it. So in your calculator, we should have 4.6 cubed minus parentheses 1/3. And those are going to be in parentheses, times our pi times the radius, which is 2.5. That's squared times 6. And that's going to be the volume left over. So if we come over here, we should have 4.6 cubed minus parentheses, 1/3 times pi, whoops, not double parentheses, pi times 2.5 x to the y squared. That was my remember to square your radius, times by 6. Oh, times, okay. Times 6. Close parentheses. That gives us 58.06, which is the volume that's left over in the tank, and round it to the nearest tenth. Since the 6th right here, I'm going to ask myself, is 6 closer to 10 or closer to 0? And it's closer to 10, so we would have 58.10 or 58.1 is the volume that's left in the tank. So there's a correction to question 7. Alright, before we do question 6, I'm going to give you your tip for the day, and that is I want to equip you with techniques or strategies that you can do to help quickly relieve your stress and anxiety. And one of those is to hit, it's called your PC6 point. It's an acupressure point. So if you go 3 fingers down, it's right here at the bottom of your 3 fingers, and you just rub it. So, and breathe in, and it just looks like you're massaging your arms. So just take a minute if you're feeling really stressed out by homework or a test, just pause, or while you're reading a question, just start massaging. Now you shouldn't massage to the point where it's painful, just a nice light massage, and do it on your other side. So 3 fingers down, and it would be right there. And so, and you just breathe until you feel like your bubbles are going to be brought down. And so these are just techniques that you can do on yourself that will give you quick help and help you manage your emotions. So that's called your PC6 point. So then question 6, consider the following prism and cylinder that have the same base area and height. So the volume of the prism is given by the formula volume equals length times width times height. What quantity can be substituted for length times width, and why? So we're asking for the volume of the prism. So here's our prism. Length times width would give us this area here, which is the area of its base shape. So we could substitute length times width with base shape, like this. So the prism could be what pi r squared, pi 2 pi r, or pi r. The length times width is the length of the prism. Length times width refers to the area of the base of the prism. That is true. And what quantity can be substituted for length times width? Oh, okay, I missed a key point. Right here, consider the following prism and cylinder that have the same base area. So even though this one is a square, the base area right there is equal to the same base area that's given by this circle. So the area for this circle, the area for a circle is pi r squared. So since length times width is representing our base area, which they have the same, we could substitute length times width by pi r squared. Question 5. Identify the formula for the volume of a pyramid with the base area B and height H. So pyramids are a portion of a whole prism, and it's 1/3 of our base area times the height of the prism. So that's something, that's a relationship you can remember to help you quickly come up with a formula for the volume of a pyramid. So question 4, consider the following prism and cylinder that have the same base area and height. The volume for the prism is given by the formula volume equals length times width times height. What quantity can be substituted for length times width, and why? Choose only one answer for each part A and B. Okay, so I'm going to draw before I forget. They give that they have the same base area and height. So this base area, length times width, is equal to this base area, which is pi r squared. So length times width is going to equal pi r squared. And so it can be, is it the diameter of the circle d? No, because d is not the same as the area for a circle. This area of a circle, yes. It is the area of the circle because they have the same base area. And volume is just the base area times your height. So y, and that's because length times width is the area of the base of our prism. So question 3, the following cone and cylinder have the same height and same base area. Okay, so again, this area is going to be equal to this area. Which of the following statements about their volumes are true? Select all that apply. Okay, I'm going to remember that a cone is 1/3 the volume of a cylinder. And so we have the volume of the cone is 1/3 the volume of the cylinder. Yep, I just said that. There's not enough information to tell. No, the volume of the cone is half the volume of the cylinder. No, it's 1/3. The volume of the cylinder is greater than the volume of the cone. Yes, because the cone is 1/3 of the cylinder. That means your cylinder is going to be larger. The volume of the cylinder is less than the volume of the cone. No, the volume of the cylinder is twice the volume of the cone. No, the volume of the cylinder is 3 times the volume of the cone. Yes, that's the relationship between these two. The cone is 1/3 of the cylinder's volume, or the cylinder is 3 times the volume of our cone. And so there's your help for this lesson.